Thank you for joining me today as I speak about the perspective behind working with external retail audit data and modeling a multidimensional system composed of internal and external datasets. My name is Rohan Pullela, and I am a data and analytics consultant at Thorogood and have drawn on our experience and expertise to bring you today's presentation. If you have any questions for me, please use the chat panel and submit your question to the host. We will ensure that we contact you directly to address any outstanding questions. You can also feel free to get in touch with us via the contact details on the screen if you wish to have a longer discussion about today's topic. We will share our contact details again at the end of the presentation. Let me speak about the different sections that we will be covering today. First, we will be talking about the requirement for external retail data, then moving to the measurement and delivery of external data. We'll then talk about the challenges encountered with external data sources, then a sample modern architecture of a database system, and finally, how we can go about blending internal and external datasets. For those of you who don't know Thorogood, we are an independent, niche, BI and analytics services firm, including strategy and roadmaps, requirements, design, implementation, and training and support. We are headquartered out of London with offices all over the world. Our clients typically span 4 data-rich verticals: consumer goods, pharmaceutical and health services, banking, and insurance, with experience across the board in various functions of these verticals. As I've mentioned, we are independent in that we don't work with one specific technology. Instead, we partner with a wide array of technology firms in the business intelligence and analytics market, including back-end, front-end, and analytics-driven technologies. We find that this independence is helpful to have a holistic view of the space, understand our customers regardless of their current data landscape, and identify the best possible solutions for our customers based upon their needs. We have been a gold partner in relevant specialties with Microsoft for over 15 years, and we have a seat on Microsoft's Partner Advisory Council, which provides us with insights into Microsoft's product and services roadmap in this space, and also a platform for feedback in terms of what we are experiencing in the market. Let's now dive into the presentation. To start with, we need to understand what retail is. Retail covers the sale of goods and services from businesses to end users who are consumers. The global retail market reached a value of nearly $20 trillion in 2020 and continues to grow due to increased income, accessibility, and industrialization across the globe. A vast number of invoices are generated each day across countries and create huge volumes of useful purchasing information. Thus begins a requirement for the collection, maintenance, and supply of retail data. This space is constituted by external syndicated market data providers such as Nielsen, Kantar, Millward Brown, IRI, Ipsos, and many more such organizations which fall within the bracket of external retail data sources. So let's talk about why we require external data. The primary objective of enterprises is to capture the market share. In today's economy, it is ever more crucial to be able to respond swiftly to dynamically changing market conditions. By tracking trends across retailers, we can improve the speed in which we respond to the change in consumer trends. We can respond quicker to business trends. We can detect new opportunities and act quickly. We can improve customer experiences through data analytics. Using data analytics, enterprises can also win over retailers, gain shelf space, and increase the outreach of their product. Availability of retail data permits businesses to track sales volumes, market shares, and derive insights into the purchasing trends, distribution, and promotion strategies of products. Retail data helps us understand the past, monitor the present, and predict the future of sales. With sufficient and quality retail data, companies can unlock reporting across various granularities in markets such as regions, areas, trade channels, etc. in a particular country. Enterprises can gain insight into not just their own, but also competitor behavior and optimize their brand positioning, portfolio of products, and growth opportunities. Supply chain logistics can also be optimized on the basis of purchasing needs to achieve a more sustained geographical growth and control over the market with the objective to maximize profits. Now that we have spoken about the need and purpose of retail data, let's talk about how the data is tracked and delivered by these external providers. The information that these organizations capture are essentially point of sales data. This is the invoice of the transaction that would be generated during a customer's purchase of goods. Typically, we have observed retail data to be supplied at two different levels. The first level is the barcode level information. Barcode level data is generally provided weekly for the products captured in sales via scanners. And secondly, at retail audit data level. Retail audit data is provided on a monthly basis and is a combination of the weekly scanner data and monthly sales, which comes in at a product code level. These data providers can also tailor specific fact data sets on the basis of the needs of the organization, which can cover different aspects of market strategy, such as brand positioning, which covers consumer demographic metrics, market structure, which covers category share, and competitor metrics. Retail data providers often have both individual market-based offices which supply a specific market-centric data and global market-based offices which supply data across multiple markets in one delivery. This allows flexibility for the enterprise to choose the data set that meets their specific requirements based on the quality of data required and the cost to acquire data. Since we are aware of how the data is tracked, let's speak about how the data is delivered and the different challenges that we experience when working with retail data. Retail audit data systems are built on top of these four pillars: time, market, and product dimensions, and fact measures. These individual files are typically delivered in either CSV or Excel format, and depending on the data provider, they are either placed in a file share location or are directly delivered into a specified location in the system. Let's now talk about what these pillars constitute. Coming to the dimensions, dimensions essentially help categorize and describe the facts recorded to provide meaningful answers to business questions. In short, dimensions are a collection of reference information about facts. Facts are measurable events related to the functional area of business operation. They contain quantitative information such as sales, that is volume and value data. Each of these dimensions have multiple attributes under them and are identified on the basis of their tag, which serves as the purpose of an ID, a descriptive entity to define the corresponding record. The dimensional data sets provided have an existing relationship with the sales data set based on their respective tags. Now let's speak about the time dimension. The time dimension helps identify the different periods for which the sales data is reported. The period tag would help identify the frequency of the data that is being delivered in the file. The data reported can be of varying frequencies such as monthly, weekly, bi-weekly, 4-weekly, and 4-4-5-weekly periods. The same market could also have data supplied in at different frequencies, which would assist them in reporting at greater granularities, and hence all these periods must be maintained separately. Coming to the market and product dimensions, they are often more complicated than the time dimension due to the presence of hierarchies. Let's speak about the market dimension. In simple terms, the market dimension helps describe the location of the store wherein the point of sale transaction would occur. Market data is reported typically across a hierarchy of market, which represents the country, region, which would describe the state or the province, area, which covers a geographical region such as Northeast, Northwest, and channel, which describes the nature of the store as to which trade channel it belongs to, like supermarkets or grocery stores. And finally, we have the market breakdown, which covers the lowest level of the market hierarchy, that is the actual store. As mentioned earlier, the relationship between sales and market is through a market breakdown tag, and the other levels in the market dimension would follow in a hierarchical fashion. Talking about the product dimension, it covers the information for products and their attributes across different hierarchical levels. Typically, we have observed products coming in this hierarchy with total category, company or manufacturer, brand family, a brand subfamily, and SKU or stock keeping unit, which would be the lowest level of the hierarchy. Retail data providers often supply fact data across these different levels, allowing for maximum coverage of an existing product universe. The relationship between sales and product dimensions would be based on the individual product level tags, and data can be captured from a SKU level to a total category level. The fact data set aims to cover the sales and share data across markets and products through a time period. Fact datasets typically provide information regarding the volume of units sold, the value generated by the sale in either US dollars or local currency, the distribution measures such as weighted and numeric, the promotional sale metrics, units purchased by the merchants, etc. And this dataset can be tailored on the basis of the requirement. Here is an example of a record that describes the sale of a stick in UK. So initially, we have these four pillars, which are composed of the three dimensions: time, market, and product, and fact. A time dimension record would basically look like this. It would have a period tag which indicates what frequency or what period in time it is aiming to cover. So for instance, here it is 2nd of August that is being covered in the time dimension. Similarly, in the market dimension, we have a market tag, and this market tag sort of helps define the store where the sale is occurring. So you can see here the supermarket ABC store 1 is the market breakdown, that is the actual store. It belongs to the channel supermarket, the area London, the region South, and the country UK. And now coming to the product dimension, the product being discussed here is an ice cream stick, and it has the flavor of chocolate. It has the size of 100 grams. And this particular product tag XYZ-ice cream C100G essentially describes the ID of the product. Finally, these three dimensions are linked to fact and are linked on the basis of their tags as displayed here. So this particular record indicates that 5 units of this ice cream stick were sold and a value of $20 was generated during a purchase that happened in supermarket ABC store 1 on 2nd of August. I hope this helped you understand the different data sets that are provided when working with external syndicated market data providers. Let's now get into the common challenges encountered when working with and while building a data model using external retail audit data. As how it has been emphasized before, the linking columns between dimensions and fact, that is the tags, help maintain the structural integrity between this multidimensional data set. However, with external retail audit data providers, these tags are often volatile. They have the potential to change across any two deliveries and hence cannot be truly relied upon. The data model would need to be structured around an immutable entity, and to handle this, systems can be built around typically self-generated or maintained IDs or the descriptions of each product or market breakdown, which would be more consistent and reliable. Secondly, the fact dataset is often delivered across a timescale of 3 to 5 years, and continuous restatements of historical data are expected from any retail audit data provider. Hence, the existing historical fact dataset would also need to be updated on the basis of each delivery to avoid inconsistent data reporting. Thirdly, the market hierarchies can often be mixed between different individual markets, leading to a break in dimension across countries due to gaps at levels. Similarly, the product hierarchies can also vary across individual markets, posing a similar issue. Maintenance of a consistent hierarchy and appropriate coverage of each level in the hierarchy is hence an essential requirement to work around this. The hierarchies can also be additive or non-additive and hence would need to be handled appropriately. External data providers are also subject to legal constraints, which leads to masking of certain product information to private label, and hence the reports that are generated against this data are susceptible to reporting against information which do not make sense or gaps in data if the masked product is not considered. The legal constraint could also apply to the enterprise using the retail data, as fact information may be reported against an incorrect label, such as in cases of complicated ownership, which could pose audit concerns during reporting. The data providers are often slow in handling changes to the information in the dimensional dataset, and this could lead to a breakage in the data reporting cycle. Thus, it is imperative to be proactive and have checks in place in the system to ensure all such complications are handled before reporting on the supplied data. These are some of the challenges that we have experienced when working with retail audit data systems. Allow me to quickly introduce the modern architecture of a typical end-to-end system handling retail audit data. So to start off with, we get the source files, which are received in either CSV or Excel format and become the raw layer of the system. The raw layer is then processed and a few set of initial transformations are performed and the creation of different levels in the dimensions are established and stored in the curated layer. Further transformations are performed, relationships are built, and this enriched data is stored in a database management system such as a SQL database. This database can be then connected via powerful reporting tools such as Power BI, Tableau, R, and Excel to perform data analytics and research at highest of speeds. Typically, it can be hosted on the cloud, with this being an example of a Microsoft Azure cloud-based system. And it can be managed using Azure DevOps for continuous delivery and continuous integration. The cloud infrastructure can also be replaced by other cloud providers such as AWS and Google Cloud Platform, and the requirements of those systems will essentially be the same. This system can provide clean, consistent data across dimensions and levels to form the basis of reports for end users. Let us now dive into how we can harmonize and maintain internal and external data sets. As we discussed earlier, the product data delivered by these external data providers is subject to inconsistencies and risks. Most organizations hence maintain their own internal product master data, which becomes the basis of all reporting across the organization. Let us speak about how we can process internal product. As mentioned earlier, internal master data becomes the major source for internal product. The increased familiarity and trust with this information being reported engages more users and can form consistent, reliable reports. Multiple source datasets could be provided by the organization, such as price segment data and consumer survey data, which would add more detail to the product and hence would need to be managed individually. The amalgamation of these multiple datasets essentially forms the internal product dimension. Even while sourcing from multiple datasets, systems can be built to exercise a high degree of control while extracting product-related information. The product attributes could be populated based on a priority order, giving the flexibility to choose the attribute from the dataset with the highest data quality. Alternatively, individual source data could also be stored separately based on the use case by adding an additional distinctive key for the source. Coming to the external product dimension, a similar structure can often be observed with organizations preferring to source data from multiple datasets, such as in this case, retail audit data, consumer data, and sales forecast data, which could all be provided from multiple external data providers. A similar flexibility to populate attributes can be offered while building the external product dimension as well. External product and internal product datasets are linked using internal product codes. These product codes, often binding at the lowest level of both internal and external product hierarchy, are supplied to the external data provider, who then encodes it while delivering product files. The strategy to form a relationship between internal and external product is, however, complicated. Individual markets can use distinct codes to form the relationship between product dimensions. Thus, we would need to implement a market-based relationship formation in the curated layer before these two dimensions are built in order to handle the variations in the binding column. A self-maintained internal product key across all the products in the dimension, which links to external product, would eliminate major concerns with multiple linking columns. Frequent changes in the dimension are expected, with new products being launched every day and older products being updated every day. This leads to an influx of information at either internal or external product source, which would not have been covered by the other dataset. All the gaps between these dimensions would need to be captured and addressed on a daily basis to improve the data quality of the system. This process can also be automated by implementing logic to ensure external products with no internal product link are effectively introduced into internal product dimension and vice versa, and are representing the right attributes of the product. The third challenge is the dynamicity of product data. Product information is often complicated. There could be invalid or incorrect product level information There could be presence of duplicates across descriptions, codes, and lack of integrity across data sources, and these are only some of the challenges that we observe. The nature of the dimension is erratic, and hence the system would need to be equipped to ensure there are preload validations done across both internal and external product. This preload validation can be performed during the data ingestion phase so that system integrity is maintained across all levels. The key to having a high-performance data model capable of delivering quick, actionable business insights through data is by pruning and maintaining efficient relationships across dimensions and measures. Using these self-generated IDs to form the relationship across dimensions, maintenance of a one-to-one mapping across the product dimension becomes simpler, allowing for a highly efficient data model. Once the relationship between internal and external product data is built, considering all these concerns, the existing relationship between external product and sales datasets can be leveraged, and an intuitive relationship between sales and internal product dimension is formed, thus allowing for users to access reports using their more familiar, reliable master data. Let's now talk about some final key learnings while working with retail data. The first key learning is the consolidation of internal product master data. This consolidation of multiple source data sets into a single dimension would enable easier tracking and reporting of products. Updates can be made more frequently and can be more consistent with the delivery. One-to-one mapping across internal and external product dimensions ensures integrity and consistency in the data model. We would also require to add corrections for additive calculations in cases of mass product information or in the presence of non-additive hierarchies, which would help in building a holistic dataset that factors in the expected breakage of fact information. Thank you for joining us today. Again, please don't hesitate to reach out with any questions. Thank you and have a great day.